दिल्ली में ज़्यादा है। So सूरज,
हाँ मैं सर उपासना सर को एक बार फिर से इंट्रोड्यूस कर लो, ऐसे तो सर पॉपुलर फीवर है।
नहीं, स्मॉल इंट्रोडक्शन
दे दो उपासना।
यस, थोड़ा सा
कंटिन्यू।
दैट्स ऑल।
I once again welcome everyone on behalf of Center for Climate Change and Water Research, Suraj Gyan Vihar University, Jaipur, Rajasthan, on the 7th day of the Summer-Winter School in Geospatial Science and Technology, Level 1 program sponsored by DST NGP. Now let me introduce to our very first speaker of the 7, Dr. Virendra Singh Rathore, sir. Dr. Virendra Singh Rathore, sir, is currently working as an associate professor in Department of Remote Sensing at Birla Institute of Technology, Ranchi, Jharkhand. He received his MS in the field of geology and PhD in the field of remote sensing and GIS. His area of interest includes natural resources, natural disaster, microwave remote sensing, hyperspectral remote sensing, surface water quality assessment and modeling, GNSS, and mineral exploration. He has more than 20 publications in various international and national journals. He is also on the editorial and review board of various SCI journals such as the African Journal of Environmental Sciences and Technology, International Journal of Earth System Sciences, Journal of Earth Sciences, Journal of Hydrology, Elsevier, and many more. With that, we are very delighted to have you here once again, sir, and would like to welcome you to start with your today's session. Thank you, sir.
Okay. So, good morning, all the participants of this winter school. Probably today is 7th day or 8th day, Suraj? I think 8th day, no? 7th day. So you have come across so many lectures, very good inputs from eminent speakers. So in continuation of my last lecture, in the last lecture, I could tell you about the transmissions signals that takes place from the Navstar GPS satellites, and with the help of those signals, GPS GNSS receivers provides us information like X coordinate, Y coordinate, and Z in WGS84 data, right? And all of our maps prepared by Survey of India are in Everest 1956 datum, right? So in the last lecture, we could learn about the sources of errors, little bit about WGS84 and mean sea level that is based on geodal surface and ellipsoid. Okay, these are the data which are used. Little bit about the coordinate system. So the problem which we face while working with the GNSS receiver is that we have information, a lot of information in Everest 1956 data and coordinate system, and the information which we get from the receivers. Okay, from the receivers, you can collect the point data, you can collect the line, polygon, etc. information, and also some photographs of the field features. And these two information you want to amalgamate, right? So a lot of information is existing with us, but the problem is that they are in different coordinate system and they are in different data. So we cannot analyze together in GIS platform, right? And we cannot, interact with the satellite data also. We cannot take information together from the satellite data also. So that is problem we come across, right? So what is the solution of those problems? You may be knowing the coordinate transformation, right? So we have to transform one coordinate system to another coordinate system so that all the data are in one system and they are spatially related and we can analyze them. So that is the thing. So we can discuss on that today. And then I would like to tell you about the techniques, surveying techniques, differential techniques. With the help of differential corrections, how can we achieve the highest possible accuracy in this system, right? So I'll start with showing you. Just wait, and let me open my PPT. Can you see the screen?
Yes, sir.
Okay. PPT is not open, right? So I don't know.
सर पीपीटी वाले आइकन पे क्लिक कर दीजिए, ओपन है शायद वो.
Open?
हाँ बस बस आ गया.
Same to you?
यस यस सर.
Okay, okay, great. So probably. Okay, so in the last lecture, I was telling you about the types of GPS receivers available in the market. So firstly, navigation type of receivers. Okay, single handheld, as a single handheld GPS receiver you can use. We will get 1 to 5 meter level of accuracy with the help of those receivers. Those are CA code based. The positioning is based on CA code, coarse acquisition codes. The frequency of CA code is lower, 1.023 megahertz, and the frequency of P code is higher, 10 times higher, that is 10.23 megahertz. So because of that reason, with the receivers which can access only CA code, we get lower accuracy. And then we have GIS application or carrier phase type of receivers. With the help of those receivers, we can get 10 to 30 centimeter level of accuracy if we carry out differential corrections. Okay, then third types of GPS receivers are survey grade or dual frequency receivers. In the last session or last lecture, somebody, a postdoc scholar from BHU asked me, can we get accuracy equal to the dual frequency receiver with the help of single frequency receivers? So that is clear, I think, from we also discussed, and here also you can see that with the help of dual frequency receivers we can get sub-centimeter level or millimeter level of accuracy. So these are the photographs of receivers available in the market. You can see the Trimble, Leica, Magellan, Topcon, Sokia. So many GPS manufacturers are there in the market, and we are having the receivers, right? So accuracy and precision depends upon definitely manufacturers. In case of Trimble and the Leica, they are tested, right? So people rely on them, but others are also equally good. So I cannot comment on that, but you can use different types of receivers. It depends upon the service as well as other factors. So I also discussed, it is just a little bit of review, the sources of error. Here in the from the picture you can get it a clear idea of the sources of error in range measurement. As I was telling you about the orbital errors. Orbit error means if the satellite moving in the orbit is perturbated, or if there is error in ephemeris, then definitely there will be shift in the accuracy. So ionospheric errors, multipath error, tropospheric errors, etc. we discussed in the last lectures. So from these sources, how much error do we get in generally? Just see, if there is error due to satellite clock, that may contribute to 3-meter level of inaccuracy in the positioning. And because of orbit errors, it can be to the magnitude of 2.7 meter. And ionospheric delay may introduce error in positioning accuracy to the magnitude of 8.2 meters. Tropospheric delay can contribute 1.8 meter of error. Receiver noise may contribute 0.3 meter of error. Multipath may contribute 0.6 error. So altogether, this error may, in accuracy dilution may go up to 10 meter or 9.4. It is just summed up. Maybe from different sources in the textbooks or from the internet sources, if you see, this may vary. It is just estimate, right? So this, in general, from my experience, I can tell that with the help of single-handed receivers, you don't get accuracy higher than 3 meters. Hardly 1 meter you reach, right? So as we were discussing in the last lecture also. But if we provide differential correction, differential GPS, so all of the errors other than receiver noise or to some extent ionosphere and troposphere can be eliminated. Most of the errors can be eliminated in differential corrections, differential GPS techniques rather you can say. But here we provide differential corrections. So it has come down to 0.9 meter, but even with advanced level of receivers and system, we can reach to the millimeter level of accuracy, right? So this can also be eliminated. Most of the ionospheric, tropospheric errors, which are 0.6 meter, can be eliminated. Other than receiver noise, all of the errors with the help of latest receivers can be eliminated. That is why we get here the millimeter level of accuracy, right? So this is the preferred technique where we are interested in higher level of accuracy. Okay, suppose you want to establish a control point, or you want to measure the tectonic movements or deformation, subsidence in all those cases, or topographic undulation mapping in all those cases, we go with DGPS, right? Differential GPS techniques. We use differential techniques, and there are many techniques in differential technique where large number of points in a day we can collect, right? So I will be discussing in the subsequent slides, how we can perform DGPS and what is the concept of DGPS, etc., and different techniques, right? So all these we have already discussed. So this is about the dilution of precision. I was talking in the last lecture also, and here I can little bit catch. So I was talking of the intersection of satellite signals, right? Suppose if the satellites are in one part of the sky, the positional accuracy is poor, and if the satellites are distributed in the sky like this, then accuracy will be very high. So people may ask why. Here the question, why if the satellites are in one corner or one part of the sky, the accuracy is poor, and if the satellites are well distributed, why the accuracy is higher? So to explain this, you can just look at these two figures. If the satellites are, suppose, well distributed, then intersection area of the signal will be smaller. It means the receiver is maximum in this area. It is not beyond the area. So maximum error can be up to the boundary of this area, which is a rectangular area here. Okay, if the satellites are closely spaced, then the intersection area would be like this, right? So if the area intersection area is more, then the dilution of accuracy is more, because receiver can be anywhere in this area. Because the area is more, so definitely the error is positional accuracy is lower. So that is the reason we look at the distribution of satellite in the sky at the time of taking observation, right? So always I would suggest or recommend that whenever, if you are concerned of accuracy in the field, you also consider the satellite distribution in the sky at the time of observation, and this is provided in the receivers. In all of the receivers in advance, you can see at what time what will be the distribution of satellite in the sky. So you can plan your survey session to achieve high accuracy, right? So for a day, suppose next day you want to carry out survey in any of the area, then you see for the next day what will be the distribution of satellite at different times of the day, right? So whenever the satellite distribution is good, satellites are distributed well in the space, so that time you will get the highest accuracy, right? So even with the single-handled receivers, you don't have suppose differential GPS, then in that case even you look at the satellite geometry, satellite distribution in the sky, because you may get high accuracy if you go with the well-distributed satellite geometry, right? So probably you have got, so this is represented by dilution of precision, DOP, dilution of precision. In your receiver, you will get information about the dilution of precision. It can be, suppose, if you look at the GDOP, geometrical dilution of precision, then what is the value of GDOP you are getting at the time of observation? If it is less than 6, then okay, the positioning can be accepted. If it is greater than 6, you don't accept the positioning because it is highly diluted. The positioning cannot be reliable. So let it come down. You wait for a point. At the point, after some time, geometry may improve and it can come down. Below the 6 is better. It can go up to 1 even, right? In case of PDOP, geometrical dilution of precision is, a representation of X, Y, Z, and the delta T. And PDOP, which is positioning dilution of precision, is the representation of only X, Y, Z. Okay, it is the ratio of standard deviation of one coordinate to the overall range accuracy. So this, what is the DOP? DOP is the measure of strength of satellite geometry, and it is the ratio of standard deviation in one coordinate to the overall range accuracy. So this dilution of precision tells you about the strength of the satellite geometry, right? And it is the standard deviation in one coordinate to the overall range accuracy. So any of the coordinate, how much it is away, okay, a standard deviation, how much it is away from that, okay, that is we can see from the value of the SDOP. Higher the value, it is more deviation. Lower the value, it is less deviation. Okay, with respect to, so value is with respect to the range accuracy also. Okay, so this is again here you can see the sigma A, which is overall range accuracy, and overall accuracy. The sigma is overall accuracy and sigma R is range accuracy multiplied by GDOP, geometrical dilution of precision. So we get the overall. So it is the product. Overall accuracy is the product of range accuracy and geometrical dilution of precision, right? So it is just that whenever you are carrying the surveying, you can consider this factor also. So that is why I just thought let it be reviewed today also. Okay, now I explained it in the previous lecture. So now we will look at this slide. Here what I wanted to show you is that if the information is in two datum, there will be shift in the coordinate information. Look at this figure, it is datum A and datum B. In the datum A and datum B, if you look at together, then you will find there is a shift. Okay, there is a shift in the origin, there is shift in the direction and in the scale also. So we don't get the information at one place. Okay, we cannot analyze the information together. That is why we perform the transformation of coordinates, right? So I was telling you about WGS84 datum and average 1956 in the last lecture. Okay, that you are knowing. Now, what is the transformation, right? So transformation, just wait, I'll include one slide here, tell you. Okay, so transformation of coordinate, right? So transformation of coordinate is to be done. That is the point. Okay, if you have one information in WGS84 and other information is in average 1956, which is in topographic survey, topographic sheets, right? Now you want to analyze both information, right? So you have to either transform the WGS84 coordinates into average 1956 or average 1956 into WGS84. Okay, both way. Either transform average coordinates to WGS84 or WGS84 to average. Then you start analyzing, because all the information will be in one coordinate system. Okay, then they are, you know, geometrically correct, right? So in transformation, coordinate transformation, two methods are commonly used. Okay, so what are these two methods? One is simple Molodensky transformation. Okay, Molodensky transformation. Just wait, my pen is not. Yes, okay. So Molodensky three-parameter transformation. Okay. In this transformation, only shift in three parameter is considered. Okay, X, Y, Z. These are three coordinates. Say in WGS 84. Okay, you want to transform these coordinates into averaged 1956. Then if you use Molodensky, then only shift in X, that you can represent delta X, delta Y, and delta Z. You get the averaged, right? You have information in WGS84 and you want to transform this information into average. So here only shift, if you know, you can get the average. Shift is derived here, a vector from source coordinate system to target coordinate system is to be known. Okay, vector. So here what we are doing, we are not converting the X, Y, Z which are in WGS84 to averaged, right? We are not converting only X, Y, Z coordinates of WGS84 to averaged. We are here, okay, transforming the frame. We have one frame, suppose, that is in WGS84. This is X-axis, Y-axis, and Z-axis. So we have coordinate of any of the point. So what we are doing here, we are getting a vector like this, and that vector is applied to this source coordinate, and we get the target coordinate. Okay, so this frame representing the WGS84 and this frame representing the average. So this vector addition is done here. This vector addition is done here, and we get the target coordinate, right? So it is a frame transformation. What is it? It is a frame transformation, right? Not the coordinate only transformation. Coordinates are not just we are changing. We are changing the frame. Okay, we are transforming the frame, and that is through the vector. So vector difference is to be known here. So that is in case of transformation obtained from the common point. Say this is one area in which you have collected, say, the built up area which is here, and rest of the information is in Everest. So you want to add this built up area to the second information. The one information, say this is this is the area which is already surveyed, and the lot of information is available with us, but this information is in Everest 1956, right? Everest, our topographic sheet. Right. Now, some additional information is there. In this area, suppose a road is going like this, and this is the railway track, right? And this is a river, and say this is another road. Okay, so like that we have some information existing in the survey topo sheet. And here you have visited the field and you notice some additional built up area. Now this built up area you have surveyed with the help of GNSS receiver, but this data is in WGS84. Always from the GNSS receiver you will get the coordinates of the feature in WGS84 until you change it, transform it. So now this information you have downloaded in your PC, and this is already there in your ArcGIS, right? Now you want to bring this information to this area. So you cannot open this together until you change this WGS84 information into Everest, or this Everest information into WGS84, right? That is why this transformation is required. This Molar density transformation is simple, 3 parameters, but it is not highly accurate. Okay, for where accuracy is not very much required, in that case you can use Molar density transformation. But for higher level of accuracy, there is another transformation that is known as Helmert transformation. That is to be used. Helmert 7-parameter transformation. Helmert's 7-parameter transformation. Okay, in 7-parameter transformation, 3 parameters of the displacement, 3 parameters of rotation, and 1 parameter of scale is used. Okay, so that for that there is one matrix, and I will be telling you. So here in Molar density transformation, if the coordinates are in geographic system, geographic coordinates, if you have geographic coordinates, obtained coordinates are in geographic system, then first you have to convert the geographic coordinates into Cartesian coordinate, right? Why? Because addition and subtraction is easy in Cartesian coordinates, not in geographic coordinates. So geographic coordinates, suppose, is say 23 degree, 5 minute and 30 second. Addition of say 1 minute here 1 minute and 2 seconds, suppose, is difficult. If you want to, if you got that this is the displacement, this is the vector which you want to add here, then addition is difficult here. That is why, first of all, in Molodensky transformation, we transform the coordinate into the Cartesian, geographic coordinate into the Cartesian coordinate. So in transforming geographic coordinate into Cartesian coordinate requires calculation of the eccentricity. Just wait, I'll be telling you the 4 equations here. X is obtained by Rn plus H, okay, and cos phi into sine lambda, right? So I will be explaining you these also. And then y, these are y Cartesian coordinate, x is Cartesian, y is Cartesian. So here the formula is Rn. Rn is radius of curvature, h is height above the ellipsoid, and cos phi and sine lambda. Here is both are cos, here is sine lambda, right? So here are both cos. Cos phi means latitude, phi is latitude, and lambda is longitude. Longitude, angle of longitude, right? This is latitude. So whatever angle you have, that you just put and find out the cos, and then calculate the Rn, and h may be given. H is height above ellipsoid, okay, in source coordinate, and then z you can calculate by b square upon a square Rn plus h and sine phi only, right? So this is the formula for calculating z, this is the formula for calculating y, and these are just Cartesian coordinate now. Earlier you had latitude, longitude, suppose, right? Now you add the differences here, whatever differences you are having. Say del x, del y, and del z. So this difference if you add, then you will find this is say WGS84, and this will be your average, right? So transformation. This is simple 3-parameter Molodensky transformation. So here you will be having problem in calculating radius of curvature, prime radius of curvature, and then rest of the things are okay. So radius of curvature, prime radius of curvature is calculated by 1 by root under 1 minus e square sine square. Sorry, just maybe just say 1 minus this is a is semi-major axis, 1 minus e square sine square phi, right? So from this formula you can calculate the radius of curvature. Radius of curvature of what? Radius of curvature is this is say your datum, and this is the center, and this is say your surface of the earth, and here you are here. So what is the radius in this direction of the datum, right? So from the center, what is the radius? That is calculated. That is known as prime radius of curvature. So wherever is your point, say your point is here, and so in this direction you will calculate the radius of curvature, and this difference is the h. Okay, this difference is the small h here, that may be given. Okay, and latitude, longitude of this point you have obtained in your receivers. So you put the value here, calculate the cos, calculate the sine, calculate, and h is given. That difference is obtained when you observe this point, and only radius of curvature is calculated. Then you can find out the Cartesian coordinate x, y, z, right? So A is the semi-major axis here, and B is semi-minor axis, right? So you should know the A and B, which are of the WGS84 support, and already I have shown you here. So this is the A, this is the B, okay, and you have to calculate the E here. E square, it will be E square, is eccentricity, right? E is eccentricity. It has to be calculated. Eccentricity is given by the formula, and that is actually, let me tell you, formula of E, calculation of E is, E directly you can calculate the E square, and that will be E square is equal to A square minus B square upon A square, right? So from this formula you can calculate the E square, okay, and put the value in the formula. You will get the radius of curvature, add the h, and find the cos and sine theta. You will get the x coordinate, y coordinate, x coordinate, and then del x, del y, del z. You have to obtain. So del y, z, del x, del z, how do you get? That is point now. Okay. So in this transformation, 3-parameter transformation, you need to know now the del x, del y, and del z. So how do you get that? So in getting those is only you have to identify some common points which are in the field. Okay, it may be the road crossing, it may be the railway or road crossing, or it may be the railway line or the river. Okay, so take the 4 points which are bounding your area. This is common point, this is common point, this is common point, this is common point. Okay, so here you find out the value in WGS84 and also in Everest, right? Here also. So for any of the feature which are bounded by these 4 coordinates, here you find out the displacement difference in WGS84 and Everest 1956, and can be applied to all the points here. Okay, so coordinates of the feature which are in this bounded area can be transformed. Okay, so that is the procedure actually in coordinate transformation. Is it okay? Now, what is the equation of 7-parameter transformation that I will be telling you, then moving to the another slide. Okay, so 7-parameter transformation can be, you know, x, y, z, target. Okay, target. We want to get x, y, z in Everest or in WGS84, right? So here, as I was telling you, in case of 7-parameter transformation of Helmholtz 7-parameter transformation, 3 parameters of the shifting, 3 parameters of rotation, and 1 parameter of scale are considered. Whereas in case of Molodensky, only 3 parameters of shift are taken into account. So that is the difference in transformation, two transformation, Molodensky and the Helmholtz. Okay, so The Helmholtz transformation is here the scale is multiplied first, okay, or you can say scale is multiplied with the rotation parameters. Rotation parameter is rotation along z-axis, rotation along y-axis, rotation along maybe x, and here you can take the rz positive, here negative, and here this unit, and here will be the y plus, and here can be the a plus, then it will be minus, and here it will be rx, and here. So like this, a metric will be there, and this will be multiplied by the x source, y source, and z source, source coordinate, and then the shift is added, del x, del y, del z. So this is the Helmholtz 7-parameter transformation. Okay, so I just introduce you, not going into the detail of calculations, etc., because that will take time and our class will go in only that. Just I have introduced you. Okay, then I'll be coming on the differential GPS. See the differential GPS. Okay, D stand for differential correction, differential GPS, right? So in case of differential GPS, there are methods: static method, rapid static, reoccupation, stop and go, true kinematic, real-time static, and real-time kinematic. These are the surveying methods, differential surveying method. Now you understand the concept of differential corrections, right? Many of people confuse what is the differential. Okay, they don't understand, but I'll try to explain you in such a way that you, after this lecture, all the times you will be carrying the concept very clear, the correct answer. So see, in case of differential techniques, how it is performed. In performing differential GPS, we need to have 2 or more number of receivers. It cannot be performed only with single GPS receivers. We need to have 2 or more number of GPS receiver first of all. That is the condition, right? So one GPS receiver which is mounted on the tripod, okay, with some attachment, and here in this picture you can see a receiver machine is mounted on the tripod. Tripod is leveled, okay, and there will be bubble which is brought to the center, so that from that we get the leveling, okay, and then this machine is mounted on it. So here we have one tripod. The equipment which is fixed over the tripod is known as tripod, and over that there will be attachment, and then this machine is fixed with that, and there will be an external antenna, right? So signal will be received in the external. So antennas are 2 types. One is internal antenna and another one is external antenna in this case, right? So this machine is fixed at one point, and it is fixed on a known point in the area. If the point is not known, known means coordinates of that points are known, x, y, z of that is known. Okay, if it is not known, then you have to make the point known. After observing this point for 24 hours or maybe sometime less, 10 hours, 12 hours, like that, you observe the point, and whatever coordinate of that point by observing is obtained can be given as input to the receiver. So receiver will understand that point as true point. Okay. So here you see in this equation, true coordinates x, y, z, true coordinate. Then there will be measured coordinate, right? X, y, z. Then there will be the difference, delta x, y, z. That is obtained. So probably you have got my message that what is the purpose of doing this. We establish a base station or a reference station. Okay, this point will be used as a reference station and base station. So here we give the input to the base station. That input is the true coordinate of this point, location. True coordinate, how do we get? Either from the secondary source, we know the coordinate of this point, or the point is continuously observed for 10 hours, 12 hours, it depends upon the area. Okay, then whatever the coordinate you get can be given as true coordinate to the receiver. Okay, then actual survey starts. Okay, so when actual survey starts, the receiver has the true coordinates given by you, and it start measuring coordinate of this point from the satellites. So there will be difference in true coordinates and measured coordinates. Why? Because of the ionospheric delay, because of the ephemeris, because of the troposphere, because of the multipath, the sources of error we discussed. So because of the biases, because of the error, measured coordinate accuracy is lower, true coordinate accuracy is very high. So there will be difference. That difference is actually the differential correction. Differential correction can be transmitted in real time by establishing connection between two receivers, radio communication that is established, okay, using the 430 megahertz frequency that is free. So local communication is established between base station and rover station. The other receiver will be known as rover receiver. This rover is known as base receiver, right? So there will be a communication, or there cannot be communication. If you have the advanced system and it has the facility of radio communication, then you can establish the connection here, and through that connection, corrections are transmitted to this point, and those corrections are applied to this point, and you get equal accuracy what this point is calculating after differentiation, after difference, okay, differentiating, sorry, okay, differentiating the corrections. So that is actually concept of differential GPS technique. Okay, differential techniques receiver, maybe you are understanding here that two or more number of GPS receivers simultaneously observe the points. Okay, simultaneously observe the point, because the error is common to this area. Why this is common? Because the satellite distance from the receiver is very large with respect to the distance between these 2 points. Okay, so consider that satellites, you know that satellites are approximately 20,000 kilometers from the surface of the earth, and this distance can be in kilometers only, 1 kilometer, 2 kilometer, 5 kilometer, 10 kilometer, like that. So the comparison between 20,000 and some kilometer is very small. So these 2 points with respect to this distance are 1 point. These are not 2 points with respect to these two. From the 20,000 kilometer of height, if you see 2 points which are separated by a few kilometers, you will find single point, not the 2 points, right? Single point. In your case, it will be the single point. So the correction, atmospheric corrections and satellite corrections will be similar to these points. That is why correction obtained here can be applied here. Okay. So what is the advantage? Why don't we get correction here? Because if you allow your GPS receiver to observe this point for a 30-minute or 40-minute, then only you can achieve the similar level of accuracy, or maybe 2 hours sometimes. So your efficiency will lower down here. Okay. If you are performing DGPS, here you need not to give observation period of 30 minutes, 40 minutes, or 1 hour, 2 hour like that. In 3 minutes of time or in minutes of time, the accuracy level equal to this point can be achieved. So you are becoming very fast here. Your survey can be very fast. In shorter duration of time, with higher level of accuracy, large number of points can be collected. So that is the advantage here. Okay, and very high accuracy is achievable. Okay, in the millimeter level of, okay, millimeter level. Accuracy in the millimeter level can be achieved. Okay, so that is actually concept. If you have any doubt here, you can ask me. Or are you getting, understanding it?
Yes, sir.
Okay. So point is that we obtained the correction here, and those corrections are transmitted to the second receiver, which is known as rover receiver or moving receiver, and it will remain throughout the session stationary here at one point. The job of this receiver is only to find out the delta difference between true coordinate and measured coordinate. Throughout the session, it can be 2 hour, 3 hour, 4 hour, 5 hours long session. Throughout the session, this GPS receiver will remain stationary, mounted on the tripod, and job of this is just to calculate the delta and transfer this delta to this point, and this receiver will continuously observing points from and moving observing point like this. Here you can see the dots and line. So at the dots, here you need not to spend lot of observation time. You just in couple of minutes you can observe this point, save this point, move to this point, observe this point, save this point, move to this point. Like that you can capture the line as well as point, large number of points. And here also, if you want to take the topographic undulations, you can move and then collect the data. Large number of data in a day of time you can collect. Otherwise not possible with high accuracy collecting so many data, right? So that is actually a concept. You can have two receiver also simultaneously. Both the receiver will be getting corrections and you will get the accuracy. Okay, so that is the differential GPS. Probably you have understood here. In differential GPS now there are different techniques: static, rapid static, reoccupation, stop and go, true kinematic, real-time kinesthetic, and all those things are there. So as I was telling you here, in the real time you can transmit the correction, and sometimes suppose you don't have radio communication. In that case, what you have to do, you have to collect the data here and collect the data with rover, and then come to the lab, download the data, and in the software you apply the correction. Okay, post processing, that is known as post processing. So there are two techniques. One is real time applying of correction, real time, and the another one is post processing. In the lab itself you have to come and then apply the corrections and post process the data to achieve the accuracy, right? So in that case, if you don't have the radio communication in your GPS receivers, you can post process the data in the lab. There is software, right? With this, suppose you have procured GPS receivers from Leica. So Leica will provide you the software. Trimble will provide you the software. So softwares they provide with these receivers, and you can process the data. Now let's discuss the techniques. Static. From the name itself, you just understand that receivers are stationary, static, not moving. Okay, both the receivers don't move. rover receiver and base receiver or reference receiver will not move during the survey session. Both will remain static. That is the static. So this is actually the basic survey technique and widely used earlier. So in what is the use of this? What is the application of static survey? As I told you that in static survey, both the receiver will remain stationary, will not be moving, only capturing 2 points, one here and another here. Okay, one here and another here. This is the base station, this is the rover station. Okay, and there can be many more receivers also. Here also you can have, here also you can have, like that. So wherever we require highest accuracy, we use this static method, right? So in this static method, a baseline is obtained. Okay, what is the baseline? Baseline is the three-dimensional vector difference between 2 points obtained by the simultaneous observations. Okay, so a baseline is established between rover and the base station, and then coordinates are obtained and it can be used to establish control points. Okay, in general, establishing control point and carrying out the cadastral mapping. Cadastral mapping you may be knowing. So you have cadastral maps, right? You have drone. You need to have the GPS receivers. 3 items, 3 equipments or 3 things if you have, then cadastral mapping with accuracy can be performed. Cadastral map you may be knowing. Do you know the cadastral maps?
Yes, sir. Village level.
Okay. So now what people are doing, they are actually converting the analog cadastral map into digital, right? So no need of going in the field and carrying out the chain survey, etc., and then map the fields, right? Now if you have cadastral map and the drone and the DGPS, you can carry out the digitization of cadastral map, right? So what people do here in performing the cadastral mapping or converting cadastral map into digital maps, that first of all you establish some points which are seen from the drone. Okay, so take some drone pictures of the area and you will have the cross points common, which are common in the cadastral map, okay, and in the images of drone. Then you observe those points with the help of DGPS coordinates and georeference the cadastral map and then digitize. So you will get the accuracy, and that can be matched with the UAV images also. So in this application, you can have the use of static surveying, establish the station, and with the help of this rover, you find out the coordinates of the control points and georeference the cadastral map. Okay, and then suppose survey is to be carried out in an area and you want to check the accuracy of that surveying. You have to establish some control points and you start the survey from that point, then close the survey at that point. If there is a difference, that is equal to the error, and if there is no difference, then the survey is accurate. So for survey adjustment, you can have control points established by static method, right? So here static methods have method has application. So in establishing control points, in establishing the control points for georeferencing, establishing the control points for survey accuracy assessment, static method is used. Also static method is used for deformation studies, subsidence land, surface subsidence in coal mining area, the subsidence is taking place. Okay, and that to the millimeter level of accuracy you can observe. And for tectonic movements, you can have a permanent base GPS receiver station. Throughout the year, the GPS receiver is observing the point, the single points. At the end of the year, you will get some vector from all the coordinates which you observed throughout the year. So that vector will tell you, is there any movement in the crust of the earth, plate of the earth, okay, top surface of the earth, and the direction. You also get the direction by knowing the vector and shift throughout the year. So people say that the Indian plate is moving towards the Tethys plate, Tibetan plate, suppose. Okay, so what rate it is moving? You at permanent platform, the platform is not dynamic. Establish the base, establish a receiver station, GPS receiver station. Allow it to observe the point for throughout year, and then at the end of the year, just see the vector whether the Indian continent, Indian plate is moving at what rate and which direction it is moving. So in different areas, you will have the vector different and in different directions. Across the India, suppose you have so many stations, okay, in Himalayan region where the Himalaya is highly tectonically active. So many seismic vibration is taking place in the Himalayan region. Okay, so if you want to know which mass of the earth is moving in which direction, and you have the fold plane, so in either direction of fold plane you can have the GPS receiver station and you observe the movements. You can say, yeah, at this rate the plate the block is moving, so that is actually the tectonic movements observation. So in those cases, in all those engineering structure, in topographic surveying, etc., this static method is used. Then there is one rapid static method. In rapid static method, sometimes what happens, you don't get sufficient number of satellite at one point of time, then you have to repeat this. Okay, then it is called, rapid static, that is reoccupation static. But in case of rapid static, nowadays in some of the receivers, a technique is used that is known as wide laning. Okay, so as I was telling you that two carrier waves are transmitted from satellite L1 and L2. These two carrier waves, L1 and L2, are suppose merged, linearly merged, then you can obtain another frequency, which is one will be narrower and other will be wide. Okay, narrower will have the wavelength of 10 centimeter and the wide will have the wavelength of 86 centimeter approximately, 84 or 86 centimeter. So carrier phase, unknown number of cycles between satellite and receiver can be resolved very fast. Ambiguity, that is known as ambiguity in GPS, and ambiguity is faster resolved and we get the rapid static. In case of static, if your baseline is suppose 15 kilometer, you need to give observation time 30 minutes. But in case of rapid static, in 10 minutes of time, a 15 kilometer of baseline can be resolved. And if the baseline is say more than 15 kilometer, then you need to have observation period of 45 minutes or 2 hours to resolve the baseline between the points. In case of rapid static, it will be 1/4. In 15 minutes or 20 minutes of time, you can resolve the baseline. So this technique, rapid static technique, is not available in all the GPS receivers. Only in most advanced receivers, this technique is available, which is linearly combining of carrier waves and obtain a different frequency. So static, rapid static, and reoccupation. Reoccupation is, as I was telling you, that sometimes you have observed some points, and at the time of observation, you did not get sufficient number of satellites. Satellite number was not good, and in that case, your accuracy is lower. So what do? You just break for 1 hour, and then again reoccupy the points at the time when the satellites are good in the satellite space, satellite number as well as distribution is good. Then you get the high accuracy, that is called the reoccupation. But the limitation of reoccupation is that you need to invest more time. Then comes the stop and go. Stop and go is very fast technique. Here the receiver, rover receiver, is static at one point and then moving another point like this. So here it is static, then it is moving to this point in all the times. Here the receiver will remain observe this point in stationary mode, and here this line will be captured in moving mode. So two options will be there in receiver. One is kinematic and another one is static. Both you have to select while setting the receiver and then perform this survey. So advantage of performing this survey is in short duration of time, you can capture large number of data. Okay. So, and if the data are closely spaced, in those cases, stop and go method is used, right? So in case of stop and go method, ambiguity is resolved in the beginning until the ambiguity is broken. This can continue at any point of time. If the loss of lock occurs, then again you have to establish the lock on minimum 4 number of satellite and then move the receiver to capture the data. Okay. Then the true kinematic as well as telling you that all the times your receiver will remain moving. Okay. True kinematic, when your receiver is moving. It can be on motorcycle, it can be on car, it can be on the aircraft and on the missile. One receiver is on the dynamic platform and other receiver can be at base station, rover receiver. So in the beginning of the session, you resolve the ambiguity, then this on the dynamic platform, one receiver will be moving at capturing the data at prior defined rate. It can be 1 second or 2 seconds. At every 1 second, the moving receiver will observe the point and a trajectory can be established. And in the real time, the corrections are transmitted. That is true kinematic. That is real time kinematic. That will be real time. In the real time, corrections are transmitted, and in the post processing, if the corrections are applied, then it will be the post processing. So there will be real time, the real time kinematic, and true kinematic. In true kinematic, the receiver is in the dynamic platform. So this is all about the differential GPS. If you have any question, you please ask.
Any question?
Yeah.
No, sir. All clear.
Everything is clear. Okay, then. So again, here you can see the example of rapid static survey. Okay, as I was telling you, and these are the things depending upon the observation period. Depends upon the length of baseline, as I was telling. So this is all about the differential techniques. Suraj, is it okay? Or any discussion? Huh?
Any question?
Yeah.
Rishabh?
No, sir. No, sir.
As you are preparing for GATE examinations,
Yes, sir.
all the questions will be asked in minutely in your gate examination. So if you've got any questions pertaining to any of the topic related to GPS, GNSS, because there is a component that has been added. So any of the candidate having any issue with any of the topic, you can ask. No one?
No question?
सर लग रहा है कि सबको समझ में आ गया सर, थैंक यू। और
ठीक है,
दूसरा
अच्छा।
है कि थोड़ा सा ये भी रहता है, डर जाते हैं मैथमेटिक्स देख के बच्चे। दोनों चीज है।
नहीं, एक्चुअली अभी जब एप्लीकेशन में जाते हैं, जब लेके जीपीएस रिसीवर्स और लेके जाएंगे, यूज करना सीख करेंगे, then they actually face the problems. So I try to clear all the issues which you will come across and the techniques in shorter time actually. In detail, if you go, each of the technique takes 1 hour to explain in detail. So
थोड़ा सा 5 मिनट IRNSS के बारे में बता देते।
हाँ, in case of I have not included the slides, but in case of IRNSS, we have satellites in very different configuration. Okay, twin satellites are also there, and those are placed at 36,000 kilometer height, right? And with the IRNS, we are getting accuracy just less than approximately near to 20 meter, not better than that. 15 to 20 meter level of accuracy is achievable in IRNSS, and it is not providing you positioning beyond the 1500 kilometers of India's border. Maybe nearby of 1500 kilometer from India, you can say. So China, Pakistan, this much of area is covered near neighboring country. Okay, information, this positioning information we can get, right? But you can say that now for getting positioning, satellite-based positioning, we are not dependent on any other country. We have our own system, and from that we can achieve the positioning. Okay, satellite-based positioning, and which is very important for our military purpose. Okay, at the time of Kargil, we were denied by getting access to the Navistar GPS services. That is why we started developing our satellite-based positioning system, and finally from 2017 it is providing us services, and for the need of our country we are getting positioning. But it still in this positioning system there are 7 satellites. We need to improve. It depends upon the policymakers whether we need or we don't need. We have sufficient, but declared accuracy from the IRNS is 15 to 20 meter, not more than that. Millimeter level of accuracy is not available there. And
sir.
Yeah.
Sir,
Yeah.
good morning. Sir, beside Dr. Divya Prakash.
Yeah.
Sir, I want to know, like IRNS, we are how much time is it expected, so that we will, like in our mobile phone, there are some mobile phones, they are using IRNS data, Navic data. So how much time India will take to use our own GPS system in all purposes? Is there any expectation data? How many? Like till now, only 7 satellites we have launched. So,
yeah, so far we have only 7 satellites, and from those satellites we are getting accuracy of the order of 15 to 20 meter, not better than that. But maybe in coming times, maybe in 3-4 years or 5 years of time, more number of satellites will be launched, and we'll be getting higher accuracy. So right now it is not announced. We don't have information that when India is going to get positioning.
And
Yeah.
currently, our defense system is using our satellite system, or they are also having 15 to 20 meter error for defense purpose also.
It is not declared actually. Maybe they are accessing, getting more accuracy.
Okay.
Not declared. Maybe they are getting.
Thank you. Thank you, sir. Thank you.
Sir, and anything about Galileo?
Galileo is actually, they are not even still opening for the people. Galileo services are also not available for the civilian people. They are either they are maybe it is limited to their uses, or if they are selling their services, that is not free. That is, they have this developed it for commercial purpose. It is not open for the civilian people. We are accessing GLONASS and Navistar GPS, and by that we are getting good accuracy for the civil purpose as well.
Okay, so I think, sir, that most of the questions has been answered, and our next speaker too has joined, Anirudh Singh from Topcon. Now I invite Upasna to introduce Anirudh Singh, and thanks Rathore sir for your enlightened lectures that all the students were benefited from it. Thanks a lot, sir.
Thank you, Suraj. Thank you.
Thank you so much, sir, for your in-depth explanation. Thank you, sir.
Thank you, sir.
Welcome, Shruti.
Now, I'd like to welcome our next speaker, Anirudh Singh, sir. Anirudh Singh, sir, is the manager of high-end products at Topcon Soke, India, with its headquarters in Gurugram, Haryana, dealing with GNSS, mobile mapping, 3D machine control, surveying application, etc. And Anirudh, sir, will be demonstrating how to use GPS for field surveying and mapping. With that, I'd like to welcome him to start with his session. Thank you. Welcome, sir.
Thank you, Upasna. Thank you, Dr. Shruti, Dr. Suraj, and good morning to all. So our today's session will be covered in two parts, where I will be, taking you to the journey of high-end products. So we will be presenting 3D point solution, mass data solution. And till date, what are the sessions I have followed? You have gone through it. 2D solutions. Today, there will be a time where I will be explaining and taking you to the 3D journey, which is the future of surveying and data production. So please allow me to share my screen. I'll be giving some presentation, and then I'll be processing the data, and then we'll be explaining the complete field to finish solution for you.
Please share it. It's allowed. It's allowed.
Thank you. I hope my screen is visible to everyone and
Yes.
my audio
Yes.
is clear.
Yes.
Thank you, Dr. Suraj. So today's session, I'll be covering mass data solution from Topcon. So to start with, I'll give you a glimpse of what Topcon is. So as you can see, this company is the oldest one in manufacturing of surveying instruments and optical technology. It is headquartered in Japan. So this company started in 1932, and over the years, you can see in 1991, first robotic total station was introduced by Topcon itself. Now in 2000, world's first GNSS system was introduced by them. And over the years, there is a lot of imaging innovation and LiDAR innovation that has happened. And from 2015 and 2022, a lot of market expansion acquisitions are happening with this company. Now, this is a Topcon global network where you can see R&D centers across the globe. And on your left side, you can see Topcon India, which is headquartered in Gurgaon. Now, Topcon has two businesses. One is IK business, the other one is infrastructure business. So in infrastructure business, we have three divisions. One is geopositioning, the second one is agriculture, the third one is construction. Today we will be discussing about geopositioning segment. Now, what Topcon add value to your projects is from proposal to mapping, design to execution. Topcon has ready-made solutions from hardware to software. So this is a product portfolio. You can see in optical instruments, total station, GPS system, laser scanning, instruments for GIS mapping, integrated systems, field controls, we provide all. Today, we will be discussing about mass data capturing solutions. So in this category, we have three products. One is called mobile, the other one is terrestrial, the third one is aerial. So for mobile, you can see on your left side, this is IPS3 HD1. It is a vehicle mounted instrument which captures your LiDAR plus imagery, and it provides you GNSS information. So this is the high-end product that you can do a survey of 200 to 300 kilometers in a single day. Now, in the middle, you can see GLS 2200, which is a terrestrial laser scanner. And for aerial, there are UAV solutions with it. On the bottom side, you can see some GNSS instruments. Now, for construction, you can see this is a product portfolio for construction. Basically, the heavy machineries are used in construction, like excavator, compactors. So for that, there are different instruments that is utilized. So this is a product portfolio for that. Now, Magnet is a family of softwares. So what you do when you go in a field, you collect your data. That data collection needs to be supported by a software. So one solution for that is a Magnet field, where you do data collection and layout with it. Now, after collection of the data, you have to process that data. So there is a software solution which is called Magnet Tools. Now, there is a new solution in the market. Your surveyor is in the field. He wanted to collect the data. You are sitting in your office and you do not want it to go in the field. So how the data transfer will happen? So Topcon has a solution which is called as Magnet Enterprise. It is a cloud-based solution. The data can be transferred through cloud. Your surveyor doesn't need to visit the office. So as far as solutions are concerned, from planning, surveying, design to execution, inspection, and maintenance, Topcon has a solution for each stage. To move forward, today I'll be discussing about 3D point cloud data solution. This is a new emerging technology that is being used in various applications right now. So as far as laser scanners are concerned, Topcon produces two products. One is GLS 2200, which is a terrestrial laser scanner. The second one is GTL 1000. So I'll talk about this special instrument at a later stage because it's not an instrument, it's a solution. On a below side, you can see a robotic total station, and on upper side, you can see a laser scanner. So two instruments has been combined in a single instrument. Now this is GLS 2200 laser scanner. It's a terrestrial laser scanner which is tripod mounted, which has a full dome field of view. It's high speed. So TOF measurement, that is time of flight. So basically laser scanner comes into two technologies. One is phase shift, which bursts the emit the lasers in a single burst. And then there is one called time of flight, which is more accurate as it take time to reflect the laser to a point where you will get the reflectivity of an object. So this instrument consists of 3.5 onboard touch screen. It has a dual built 5 megapixel digital cameras. One is wide angle camera. And if you wanted to have a more detailed information of your feature, then you have to go with a tele-angle camera. Now, as far as methods, data registration methods are concerned, you have backside to prism method. You can use resection method also with this. So your data comes registered from the ground itself. It has automatic height measurements. Now this is GTL 1000, a snapshot of it. So earlier what was happening for layout information, you were requiring a total station, and to capture as-built information in the field, you were taking a laser scanner. So what Topcon introduced a combination of both, where you can do a layout and you can capture it as-built in the field. Now, as far as solutions are concerned, there are many applications. You can use it, but today I will be discussing about 3 solutions. So one would be volume calculation. This solution needs to be done in mining, most of the times in mining field, and then where there is a stockpile, you need to capture a volume out of it. So let's see to it how this information would be captured. To understand how laser scanner will work regarding your, against your GNSS and total station. So let's capture a point of a surface from total station. This is the same example you can capture with GNSS also. So you require a two person into that. A total station has been mounted. One person will be handling a prism. So what you do, you take a point. For the next point, the person is moved forward and desired point would be captured like this. So you'll get a very high accurate data. But three things that will be hindering your automatic process would be, there would be a lot of time that would be taken, labor cost is involved, and there will be other cost of processing this data. Now, let's see volume measurement using total station. So as I've already explained, you get accurate points from total station. You can do a proven method of occupation backside and resection in registering your data. And then it's a very tedious process. The time taken will depend on the number of points captured, and less number of points leads to low accuracy. So let's sample a project where we will capture a surface from a total station or GNSS. So this is a total station or GNSS surface. You take points like this. So what happens when you create a surface, the surface will not be exactly captured and the density of the points is very far. Now we understand of point capturing of surface by 3D laser scanning. So a single button, what you get, millions of points, 360 degree. And each point will contain your XYZ coordinates. It will be high efficiency, the density would be very high, you will get a more accurate data. So what are the benefits of using a 3D laser scanner in volume measurements? You capture points using terrestrial laser scanner. It's a very easy process. The same proven methods of registration of your data, like occupation backside or resection method, can be used. It's a one-touch button to capture point clouds. Very easy operation. You capture dense points clouds within a minute. Your volume calculation will be very accurate. Let's sample this by capturing a surface through 3D laser scanner. So what will happen as the density of your points increases, you capture exact surface out of it. Now, moving forward, while doing a survey through GNSS or your total station, you capture only points. So you do not capture the exact site information available with it. You need to revisit your site to capture other features which are present at the site. But with laser scanner, all the information that is available on the site will be captured like this. So let's sample how much time it takes to capture site information or as-built information. So for volume calculation for a stockpile, what you see on your right side is a volume stockpile, and it is scanned by GLS 2200. Total 8 number of locations were scanned out of it. It took only 5 to 10 minutes per scan per location, 8 minutes to generate point cloud and do stitching, and it was 4 minutes to export Autodesk format point cloud data. This is one snapshot of your stockpile, and this is a 3D point cloud data in an intensity view. As you see in a blue orb, these are the imagery in softest. When you double click it, the imageries will open up. So you will be able to identify the details or the elements that is present on the ground. Moving ahead. Now the introduction of GLS 2200, it's a long, you can do a long distance scan. It comes into 3 models like 500 meters, 350 meters, and then 130 meters. It's easy setup, high speed scan with a dual camera. It has a 360 into 270 full dome scan. It has a very high accuracy by integrated precise scan technology, which is patented one that removes noise while you capture the data from the ground. Moving ahead, it has multiple applications. Now the range depends according to your applications. So you can do facility management. It can be utilized in BIM. You scan large structures. You can do tunneling, tunnel monitoring, historical architectures, road construction maintenance, and then of course volume calculation, which I was talking about. So this is like the modes on which your data will work. So it has different modes to capture the data. If you wanted to go with a detailed mode, it utilizes laser class 3R, then high speed, low power, standard, and close. So standard one will give you the longest distance. So this is the scanning time. So for 25 mm at the rate 10 meters, the measuring time would be like 40 seconds. So you can control the density of point clouds or spacing between 2 points by choosing a scan interval while scanning the data. Now, efficient measurement methods, that means how you capture the data. So you have tie point method where you stick target points. You capture the data like occupation point 1, occupation point 2, and then later on you tie the 2 different point clouds from different stations in a software. So it's high accurate, but it's labor intensive. The second one is shape matching method. So if there are features present that you can identify later on while capturing the data, you go back to your office and then you match this shapes, which is high speed, it's easy, but it is not that much accurate. Now, the best method to be utilized in the field is occupation and backside. The next one is resection method. So in this, you will utilize a prism. It can be 360 prism, -30, -7, whatever the prism you will utilize in field. So it requires a bit of knowledge, but data will be very accurate. So moving ahead, efficient operation, auto height measurement. You can see it's a one-touch scan. It rotates like this. And then there is an auto height measurement. So you don't need a tape to measure the instrument height from the ground. Automatically, that will be captured in the field itself. So it saves a lot of time. Now, this is one video I would like you to go through so you'll understand the product which I'm talking about. Let's move ahead. So what will be the workflow process for this instrument? So initially what we do, we scan our site, then we take this data do merge or georeference data. If you have utilized occupation backside or dissection method from the ground, this step can be skipped. We clean our data and then we extract and analysis this data and we produce deliverables out of it. So the software which do the post-processing as for Topcon products is Magnet Collage, which is a immersive point cloud software. So it has a very easy ribbon layout with large buttons, able to handle large files with ease, and you can, simple export to third-party softwares for finalization of this. What you're seeing on the screen is right now you have done scan 2 sites from different stations, and you are registering both the clouds in a single way. So it's very easy to register the data if you have not utilized the standard registration processes in field. So what are the functions of Magnet Collage? You can import your GLS 2200 data. You can do registrations. You can visualize your data in intensity, RGB, and elevation modes. You can clean your data. So most of the times there would be noise present at your site. The data cleaning is a part of your exercise when you utilize Magnet Collage. Then you can create DTM contour and you can do volume calculations out of it. You export this data to various third-party formats. So these are the formats. These are the standard industry standard specified formats. So the common one is like .E57. The RCS is a Autodesk format. Then TXT CLR.LS is also a very common format used for LiDAR. Then PCD, PTS, CL3 formats. For registrations, you can utilize occupation and backside and dissection. This is one thing. The data comes registered from the field. And if you wanted to do a free scan or you don't want to register data from the field, then you can come and utilize manual and cloud-to-cloud matching registration methods in the software itself. Now, how this volume calculation workflow will happen in GLS 22,000. So supposedly at mines, industrial plants, supposedly fertilizer plant or any industrial application, you have to measure your stockpile. So this will happen like for as-built information, you will capturing with GLS 2200, you take this data to Magnet Collage, and you can do a volume calculation in Magnet Collage also, but the most preferred way or industry uses Autodesk Civil 3D to calculate volume. So you will be creating a 10 surface and you will perform accurate volume calculations out of it. So this is one example how to get your volume calculation correctly in Autodesk Civil 3D. So the first thing would be you have your point cloud data of a stockpile. What you do, you define a AOI or area of interest for which you wanted to analyze a volume. You'll create a surface that will be kind of a tin model. So right now the AOI is being defined. So you can see out of your scan site, you have taken out the stockpile on which the volume calculation would be performed. Now, we will be defining a surface and you will be providing the ranges on which you will be defining your stockpile. So for color schema, you can choose different colors to highlight each layer. So you can see minimum elevation and maximum elevation is defined. And you are providing a color scheme to identify different levels in this stockpile. Now these are the surface properties. So we'll define elevation. So you can see it is being identified in different colors. The next thing you would be highlighting reports. So generally the contractors, they do stockpile volume calculation in mining industry. Supposedly it's a mineral mine, dolomite or lime, or in coal sector, you can see a lot of this thing happening as an application. So the contractors do it into civil 3D like this to define different layers, and then they publish reports which needs to be submitted with the agency to approve their BOQs, like billing of quantities. So this is how this activity is being performed. So now for each layer, there will be a different volume that will be defined. And you can see right now, you can see minimum elevation, maximum elevation, area, and which color code we have given over here. So right now you can get a volume for specific layers. So moving ahead, what happens when you utilized either total station or GNSS? You have to manually measure your point. That the data quality is not that great, and generally in summer's time you cannot climb the stockpile, especially coal, due to safety reasons, so unfavorable site conditions, and you lose a lot of money as the accuracy is always hampered due to less point collection in the field. So application analysis of GLS 2200, let's see to this. Either you do tunnel monitoring, bridges, roads, stockpile, architecture, you can utilize this product for that. So you can see in a single project how this instrument or laser scanner instruments can be utilized for simulation, drawing. You can create 3D BIM models out of it. You can do structure calculations, energy analysis estimation, then time schedule management and material management can be done through this product. This is one documentation. So how accuracy is defined. So you have a construction site where there is a lot of soil movement or mining area is there. So the objective of this, like managing of volume, planning of construction or disposal of soil or any material that is present on the ground. So as in deliverables, what you will be giving, one would be volume calculations. So stockpile calculation can be done. You will draw 2D drawings, then 3D models, contour and cross sections can be drawn out of it. So for this kind of a application, you will utilize a laser scanner, which will have more than 350 meters of range, and the accuracy that will come like 5 to 6 mm with it. Now we will talking about some of the BIM. That is a very emerging industry, like building information modeling, and a lot of construction companies are utilizing this technology. So let's ask this question: is total station data enough for as-built? How to quickly finish the job? Do I need a scanner data for as-built? Is it difficult to register scan data with control points? So Topcon identified this problem. Now they have a combination of total station and scanner for BIM applications. So then comes this solution, which is called a GTL 1000. So you see, this is a robotic total station, and it has been combined with a laser scanner. Then your GTL 1000 is being produced. What is this? With a lower body, that is a robotic total station, you can do topo data plus layout, and for as-built information capture, you can utilize a scan. So let's see this video to understand why this product is being required. Moving ahead, so this is GTL 1000, which is laser scanner total station. It's fully robotic with added scanner functionality. You can do scan and layout. It's very fast, easy, and very productive. So as far as lower body is concerned, it is a robotic total station. What you do with it is like auto collimation and auto tracking functionality. What is auto collimation? So right now, when you use a total station, you need to have a center of prism marked manually. Now with auto collimation, you roughly put your robotic total stations toward your prism, and automatically it will mark your center of the prism. Then auto tracking functionality means if you are utilizing a prism, you can log that prism with your robotic total station. So you don't need another manpower to, with your instrument. The instrument will rotate directly with the face of your prism. Then you can do offset measurements. Then direct navigation you can have with laser pointer. Moving ahead, the upper body, which is a scanner one, so you can do a very accurate scan. So the range of this product is 70 meters and the speed is like 100 kilohertz. So 100 kilohertz is like 1 lakh points per second. GTL 2200 is having around 1 lakh 20,000 points per second. Now the surface accuracy of this is like 5 mm 10 meters. It has one camera, which is a wide angle 5 megapixel camera. So as far as scans are concerned, it has two modes. One is called standard mode. You will have a pixel point spacing of 22 mm at the rate 10 meters. It takes only 40 seconds to do a 360 scans. Then there is one fine mode, which is like 11 mm at the rate 10 meters. It takes around 2 minutes and 46 seconds to do a complete 360 scan. Now, so this is one example. If you have not done the registration or utilize the registration method, occupation backside of the resection method in the ground, you do a scanning from two different stations that will be called as point cloud A and point cloud B. You come and register this data to various methods that I've already explained in the previous slides. This is one snapshot of a steel structure in intensity view that has been captured with GTL 1000. Let's see how this instrument works out. So moving ahead, let's see the operating procedure for it. So for field data collection, you will be utilizing software which is called as Magnet Field, which is very user friendly. You don't require any training. If you have already operated a total station, you will be utilizing the same occupation backside and resection method out of it. Now, it has an added functionality of site scan icon, so you can scan your site for as-built information. So this is how it happens. You create a job and then go into setup, you configure the data, and in site scan option, you start your scanner. So your scanner would be started. Now there would be scan types, means full DOM is a like 360 view. Then you can, if your area of interest is less, you can use an area, you can define an area, the data will be captured for that. Now, if you wanted to take an image, that means imagery, the option is given, you can on and off that. And then for scan resolution, I've already explained it has two types, standard and fine mode. So sometimes you forget, to off our lens cap. So that was the message. So shooting means it's taking an imagery right now. So this will be the dashboard that you will see on your instrument while capturing the data. So moving ahead, the same software would be utilized for this also, which is magnet collage, and you can perform the several activities through this. Now, the registration method I have already explained in my previous slides, and then these are the third-party formats that will be utilized for this. Next is total station versus laser scanner. I have done a comparison why you will move to a more 3D environment rather than going to 2D, which is only a basic of surveying. So as far as quality and accuracy is concerned, it's a single point measurement, which is not enough to calculate the stockpile volume accurately. You need to climb up and down the stockpile. You lose money due to miscalculation. Now, if you utilize a terrestrial laser scanner, you will have a better quality and accuracy as you are capturing millions of points. You have a safety because it's a long distance range capability. You don't need to climb the stockpile. It will save you a lot of cost as you are having accurate volume calculations out of it. So this is one application that I've spoken about, which is volume calculation. Now I will move to a construction industry. So let's see what is happening in building information modeling that is being used in this construction industry. So let's start with the traditional one. Earlier, we were utilizing 2D drawings, which were CAD-based design drawing. So information was dispersed at that time. You need to update drawings, which was taking a lot of time, and there was printing cost attached to it. Now, this segment has moved to 3D models, which is automatic drawing updates. So you are utilizing softwares, and then you do automatic quantities. Construction XYZ data is available, and you can visualize it before running construction on the field. Now, there is a lot more that is happening, which is called as Bim Collaboration Models. You can do project coordination and quality with it. You do analysis before, putting up instruments on your construction sites. You can do simulations in 4D, 5D, now up to 11D, you can do it, and you can have a digital as-built quality analysis through it. So this infrastructure segment is changing. Then apart from 3D, now the companies or construction infrastructure companies are moving to a different segment, which is called 4D, 5D, and 6D. When you attach 4D to your project, that relates to time. When you attach 5D, that is dimension, fifth dimension, that will attach to a cost. And 6D relates to maintenance of your project. So this is a BIM cycle. So you can see it's a process actually of different stages that will be involved in construction of a site. So from conceptual design to a detailed design, you go with analysis, then you produce documentation, the construction starts. There are construction logistics that is involved. You do operation and maintenance. And later on, you do a demolition, then you renovate, and the same cycle is run in a loop like this. So for more demand, digitized and 3D model cycle projects, what you give as-built information, you do a lot of maintenance, simulation, and management. So you see, this is as-built information that is on the site. You simulate the data, that means you see and visualize, you manage it, and later on you maintenance the site. So this instrument will be utilized in different applications, the same functionality as like GLS 2200. Let's move to a segment which is a software called as Colorize 3D. So this is a scan to BIM workflow solution. So as far as hardware solution is concerned, I have already explained our two products. Now let's move to software solution, what we are giving to our clients in processing of 3D models. So Colorize 3D, it has three softwares. One is Edgewise, which is an automatic modeling software. One is Verity, that is construction verification software, and then Rhythm is a flow fatness analysis. So for scan to BIM, you collect the data, convert into intelligent 3D model, can be used for remodeling, facility management, construction coordination, and more. So what is this new tech and what is the workflow? So in the field, you utilize your hardware, either GLS 2200 or GTL 1000. You register your data into magnet collage, and then the modeling will be performed into Edgewise, and final products will be delivered into as desired softwares like Revit, AutoCAD Plan 3D, AutoCAD, Aviva PDMS, CADWorks, and many more. So earlier, what the industry was doing, they were scanning the data in the field, they were registering it into a software, and then this data was taken into Autodesk Revit. So the process was very manual, like to create or select a family, put family along point cloud, you do creating a section, you were adjusting side. And then this data was taken to Revit for finalization of your 3D models. Now what Edgewise gives you, you scan, register, take this data, whole this manual process is being done now by automatic or semi-automatic approach. Then you take this data to Revit and you finalize the model. So this is a complete solution where you do a scan layout process, you extract the data into Colorize 3D Edgewise software, then you take this data to Autodesk Revit or Autodesk BIM 360 for finalization. So what is Edgewise? It's a field to finish solution for automatic modeling. This is as-built modeling platform. It utilizes advanced algorithms to automate tedious scan to BIM workflows. It models as-built pipes, structure elements, duct, walls, conduits, and cable trays from mobile and terrestrial point cloud data. So this is Edgewise. It creates fast and accurate as-built BIM and CAD models. You can extract structure, pipe, conduit, ducts, and walls, cable trays that is present on your site. Automated technology that reduces modeling man hours by 50 to 75%. In case of industrial plants, if you are extracting pipe, it reduces your modeling time by 95%. So it is compatible with all major BIM and CAD softwares like Revit, AutoCAD, MicroStation, SolidWorks, and many more. So why Edgewise is compelling? It do a lot of automatic extraction. So it complete over half of model with 0 man hours. So don't need to model any data, just insert your point cloud data. And these models will automatically turn out in your software. So it has a comprehensive QA tools to verify accuracy and fit of every object. It has patented technologies like Easy Connect tool. So there is a situation like in upper snapshot where you can see when you scan a site, there might be a hindrance. You are not able to collect the data and there are gaps in your data. So this software with Easy Connect tool will connect these with straight connectors and elbow connections. It has a rapid element extraction technology for structure and ducting, and pattern extract, which is a patented technology. So repeating elements will be captured automatically out of it. So it has a direct integration with Revit, Plan 3D, PDMS, and CAD. So data can go in and out from this software without any problem. So this is one snapshot of steel structure. This is a basement facility that is being done by GTL 1000. Then the data was taken through EW, like Edgewise, and later on the final model finalization was done into Revit. So this is not an imagery, this is a point cloud data, what we are seeing right now. So this is one piping workflow, how the extraction is being completed. I'll show you later on in my live demo. So this is like some of the case studies where this solutions has been utilized for MEP projects. So this is structure workflow. I'll show you in my upcoming session with live one. And then these are the advantages of using Edgewise software. So this is one workflow if you are working on an industrial plant data, like Autodesk Plant 3D is a software which is commonly being used to CAD model your 3D point cloud data. So same process, you take your data to Colorize 3D, you extract 3D models out of it, and then you finalize the 3D model into Autodesk P3D. So this is one piping workflow for the same plant P3D models. So these are some snapshots how to take this data. This is the last one, how you capture your pipe 3D models into your Autodesk Plant 3D. So this is one video I would like to highlight where in a single project, all the technologies like total station, GNSS, UAV, laser scanner, and mobile mapping is used in a single project by Topcon. So this is your laser scanning. This is GNSS survey. This is hybrid positioning. Upper side, you can see GNSS. Lower side, there is a 360 prism that has been utilized. And it is connected with the total station, robotic total station. So that is auto tracking, which I was speaking about. Now indoors, a laser scanner will be utilized to model your 3D elements or objects. This is one software which is called as an Orbit, which is used for feature extraction for mobile mapping system. So let's move to a live session of Edgewise plus magnet collage where I'll show you the data, how this looks like. So before I move to my software part, if anybody has any queries, please do let me know. Are we good to go for the software part?
Anyone? Any question? Dear participants?
Anirudh sir,
Yeah, please.
all the instruments you have shown there, those are providing mostly the data on Autodesk environment.
Yes. So what happens in industry, majority of clients, which I have seen, like 60% of client is utilizing Autodesk products, but this can be done on Bentley products or any other products which is being desired. You can transfer your data with the same.
We expect directly data on Esri softwares or kind of GIS softwares.
Yes, you can do it the same format. Actually, Esri softwares utilize .ls format.
Yes.
So you can transfer your data into alias format, and then you can utilize Esri formats with it.
First, we need to take it into the Autodesk environment, then we transfer it to whatever format we require.
No. What happens, irrespective of a manufacturer's make or model, you need to take this data to post-process in their software first, because they are generally binded with a native format of that manufacturer. So supposedly the data from Topcon comes into .sta format. You need to process this data into magnet collage, which is provided with the package, and then you can, from here itself, from magnet collage, which is a post-processing software, you can transfer this data to .ls format and directly take it to history products.
Okay, thank you.
I hope this is clear, or should I elaborate on my answer?
No, it's fine, sir. Thank you.
Thank you. So any more questions, or should I move forward to the software part? Okay, let's see the data then. Yeah, let's see the data. So this is a magnet collage, which is a post-processing software. What you need to do is you need to add your existing scan, or you can create a new project scan from this data. So right now my data has been scanned. To save on time, what I have done is, let's see the data which I have done for a mine project for volume calculation applications, which I have talked about in the previous slides. So let's jump to this. So right now what you see the data, it is in 2D format. So generally when you work with total station or GNSS, you capture point like this, which is in 2D environment. So that is not gives you an exact identification of your surface. So let's swap this map, and when you swap this map, the data turns into 3D. So this is a coal mine, and what we're seeing the data in an intensity view mode. These are the benches of coal. For your understanding, what I'll do, I'll change it into image view so you would be able to understand it more. So there are different visualization modes. Now I hope you would be able to see this data more clearly now. So these are benches, like this is one bench, and then they do excavation of this, dredging of this, and then they work on this bench. And in this way, this is an open cast mining for them. So let's see if you identify the elements that is present on the ground. We can utilize imageries also. So this is a blue orb. The imagery was captured with GLS 2200. Let's double click this. It changes the whole environment. Now you will be able to see the data more clearly. This is a 360 panoramic view that I have already processed in this software. So let's swap our panorama. I'll go more deep to show you this data. Supposedly, let's go over here. These are the stations that is being captured. So this is one more closer view of a bench. And what you see, this Black portion, this is a coal that these companies are mining from this side. So you see a black portion in your point cloud data. This is because due to the water actually that is present on the ground. The data consists of around 2 kilometers of these benches. These are heavy machineries that is working. Let's swap the panorama. So just for your understanding how this capturing has been done, what is point cloud data? So for this application, companies majorly use volume stockpiling volume calculations that has been performed through this. So it's not possible for you to do this with a GNSS survey or total station survey to capture these benches in detail. So when they excavate this site, the whole material falls down, they create a stockpile, and then they would be able to generate billing of quantities on which their billing is being done. So let's change into intensity view for this. So just to give you an idea how this data looks like and what are the different functions or features that you can do with it, I've shown you this mines. So you would be able to understand what is point cloud. Now moving ahead, I'll take out this, I'll show you one more data. So this is taken from GTL 1000. It is an overbridge to create 3D models. So as you can see, this is the Gurgaon area. It is a lot of data. So the instrument captures around 1 lakh points per second. Each point will have XYZ coordinates available with it, which is not possible with basic surveying instruments like total station or GNSS. So I'll change this into intensity view mode to image mode. So let's see to it. The purpose of today's session is to show you, apart from surveying from GNSS and total station, the technology is advancing and you will be surely seeing this instrument on a regular basis at your sites. This is one, which is an elevator. Let's move out of this. So if I'll take out only one station, these are different stations. And from scans, what you can do, you can check out your LiDAR. Then you see. This is ABW Towers, where Topcon is headquartered in India. So this is just outside of this office. And if you wanted to own your point cloud data, just simply click on this LiDAR images. So just to show you in images, these images were captured 360 degrees, and later on the panoramic view was created while processing this data. So if you wanted to process this data, there is a process scans and images options. You can go over there. So colorize scan from images, that means this point cloud data is mostly panchromatic or black and white. The color comes from the imagery itself. The software do it automatically from here. You can stitch your panoramas. When I'm moving like this is 360 degree imagery created. So it's a panorama that is these images are automatically stitched. So let's move to intensity one. So this is the features that will be captured. Now let's move to our third application, which I have shown for building information modeling. Discard this. Now one product which is called Edgewise. This is an automatic modeling software. It creates 3D automatic 3D models from your point cloud data. So this is the interface of your Edgewise. So one option which is called process scans, that means you need to pull your data into Edgewise from this window. So there are three options that is available. One is called structured workflow. The other one is unstructured workflow, point database workflow. So structured workflow, actually, when you have scanner locations available in your data, so that is like structured data. And when you do not have scanner locations or XYZ information of your instrument, then this data becomes unstructured. So what you are seeing, the file types, these are the common file types, or majorly all the file types that is being utilized to capture your data or 3D models. So this .dp, .e57 is an internationally recognized format. The data can be structured and unstructured into this format. Then .fls is a FARO one. .ptgpx, the Leica, you have heard about the company, that scanner creates. .rcp is a recap format, Autodesk format. Then tzf is the Trimble one. ZF is a Zolek and Fowler scanners. So irrespective of model and make of any manufacturer, you can call your data directly after scanning into this software. So when you use a structured workflow, so supposedly you see this data, I'm calling one data which is like industrial plant data. I'll show you how the industrial plant data will look like. So you see automatically you can create building, piping, ground from this. So you create a point database out of it. If you check out, it will automatically extract walls. The piping would be automatically extracted, and you can generate a surface out of this. So to save on time, I have done it previous only. So I'll just open the model, how the data will look like. So this is a database file we have generated, and then this is for piping modeling. So I'll open this data. So what you're seeing right now, these are the pipes for an industrial plant that is automatically being generated without any intervention, manual intervention in the software from your point cloud data. Now, this is your point cloud that was captured through GTL 1000. So how modeling can be done through this? I'll show you in a very brief moment. So let's take out this point cloud right now by pressing Z button. And then we need to go into this piping model segment. The first thing we need to understand is a smart sheet, which is a QC sheet, which is a very intelligent spreadsheet. When you go over here, you see for each segment, when you click on something, you see over here that has been highlighted with a point cloud. So the length has been defined. You have a band radius, diameter, but nothing like nominal pipe size, subtype, type. These are not defined because generally this will be defined after you will apply your standards to it. Let's move to it. See, there are gaps in this data, how to fill with this. You'll use your Easy Connect tool and you'll just run it. Now you can see your pipes are connected with the straight connectors and elbow connections. And if you own your point cloud data, you will be able to visualize this. Now the next thing would be, since these are connection, we need to make it as a true pipe. You have to run clean pipes tool. So when you run this, all your data becomes as a true pipe. So now these pipes has turned into 2 pipes. The next thing, you will apply some standards to it. So standards is basically been defined on which your project working, but these are customizable also up to your project. So the common one is ASME, and then it has DIN-BS, ISO, GIS, Korean. You can utilize any of it. Right now, I will be utilizing the ASME standards with the pressure rating of supposedly 150 PSI and OK. Now I'll just go back to my smart sheet and check what changes it has made. So you can see now it is more accurate and standardized way. We have a band radius, then a diameter with a nominal pipe size of inches. Then you have a pressure rating that has been applied to your all pipes, or you can apply it to individual pipes as required. The standards of ASME has been applied. And we have defined as a Revit family. So supposedly you wanted to change this information for these 4 pipes. There's a multi-select options over here. You can put up a layer. Layer is like gas layer, and you see your layer is defined as a gas. And then supposedly for these pipes, you wanted to change the Revit families. Later on, we'll be utilizing Autodesk Revit. So you can go directly to a multi-edit tool. From here, a Revit family, you can define it as a conduits also. So you see these pipes has been changed to conduits. And in this way, you will be able to do around 95 to 96% of your modeling that was earlier done as in manual. The best way to view this is like over here. I wanted to show you one more very good feature of it. Scanner locations, the data which we captured. So these are different scanner locations. You will be able to see some green orbs. When you double click this, the software has a very good feature. So this is not an imagery. This is a point cloud data only. This point cloud data is being changed into photorealistic view. So you will be able to identify your elements that is present in your data. And later on, this will be modeled like this. If you wanted to move forward to another locations, just double click on a next screen. So this is more photorealistic view of this. Now, there are other things that you can add into data is, so let's change it to our database view. These are the elements that needs to be attached with this. Like if you wanted to attach walls and flanges. So there are options that is given over here. And then you can use a straight pipe reducer T-joints in this data. So supposedly you want to put up a flange. I'll take out my point cloud data so you can see it clearly. So let's use a wheel neck over here. You can see I've added an flange, wheel neck flange over here. And then if I wanted to add a gate wall, I can be able to do that. And there are rotating functions, so you can generally fix the rotation, and then you can slide it this to exact position where you wanted to slide this. The last thing in this I'd like to show you is go into a file, and then you can export directly this data to Revit, or there is an option which is called an export. So in pipes, you can use multiple formats or whichever third-party software you are utilizing, like AutoCAD, MicroStation, PDMS, PCF, Plant 3D formats, and this data will be transferred along with your point cloud data. And later on, you can build on this to create 3D models for this. Why this is required? So supposedly you are working in an industrial plant. They have a very limited period of time of maintenance. Like supposedly they target only 20 days in a year to change aging features like pipes or something, you can create these, and later on that 20 days will be cut down to your 7 days of your maintenance. So more, it gives you more productivity. If you have 3D models, you can change it directly without having inspection or something, because you can attach it with the number of years they will be functioning, or any issue that has been created while functioning of this industrial plant. So moving ahead, I'll take out this model. I'll show you one more, which is called as structure model, how to build on that. So I've already processed that data also, just to save on the time. I'm opening one model. So this is one which is called as steel film project. So I've opened this data, and then I will open one structure. So this is how a steel structure would look like when you scan with a laser scanner or any laser scanning machine. So this is a steel structure. You can see your beams and columns. Now to start with, what you can do, there are different, you will go into structure tool, and you will select your standards. So there are different standards for different elements. For steel, there are AISC is a common one. Then you can use a European, Imperial, GIS, Korean, or metric one. So right now, supposedly I'm using AISC steel. Then different elements can be mapped with I-beam, round tubing, truss tube, angle iron. So you need to choose that to match that. And there is two options, which is called auto fit. Let Edgewise decide what is the best fit for your beam and columns, or there is specified dimensions available to it, and it will be mapped on that basis. So right now I am giving Edgewise freedom to decide what is the dimension for this. Next, there is a spreadsheet built into this. What you can see right now, you click on this, you see the same beam and column into this. Now, what you see in a green is your point cloud data, and on which the automatic modeling is being done. So I'm okay with this, and let's see if I can build on something. So if I wanted to change this, there is a resize option that has been given. You can resize it as per your satisfaction, and you can move it to make it more accurate. So like this, we will be building our spreadsheet in a 2D mode also. The next thing would be to see, I've already created or extracted this 3 beams and columns. What I'm going to show you a automatic process. So this is our beams. I'll be using a patented technology, which is called pattern extract. And then so you see automatically this side, if you see a point cloud data, this side is automatically created. If I'll move to next, and then I'll push my shift button, I'll select my beams and columns. I'll use this pattern extract, and then I'll lock my orientation. You see within few clicks, all my whole steel structure, I would be able to model. So if I own my point cloud data, you see this side of this portion is completed now. Later on, we will do some QC on that. Now I'll select this side of a portion. I'll use the same pattern extract technology. I'll take out my lock orientation. So it will work on the same dimension that is available because these are repeated patterns. So it will identify. Now this works totally different from the algorithm that we have just extracted in pipes. So in this object recognition, object-based recognition algorithm is being utilized to identify these elements in structures. That same goes with your ducting and walls. So let's see to this. Now you can see if I on my point cloud data. So this is in map now, automatically within few clicks. Later on, if something is missing, I can see one. If supposedly your software is not able to identify something, I'll delete it on purpose. So you can utilize a semi-automatic approach also. You own your point cloud data, use a autofit function, use a extract function, and then you can semi-automatically also extract this whole thing. So you see, this has been extracted. Now this is being short. So you can use your extend button. So this beam will be, this column would be attached, beam would be attached to your column. So I'll use my extend button over here. Now this has been done. So this is for your structures. In this way, there are other models that you can build, like cable tray. The ducting can be done, and you can use walls functions with it the same way. I'll show you the walls one. How the building is being constructed. So I've already processed the data and extracted the walls. So this is a point cloud data for your building, which is under construction, or if you wanted to do a renovation. So I'll take my point cloud data. So you can see these are the walls which is automatically being created through this point cloud. Now these labels is generally generated because of different floors are there. You wanted to model it. If you wanted to give your own labels to it, it's a possibility. So supposedly if I would like to add one label on this window sill, so I'll go into this pick label from points and close this, and I'll pick it. One more layer would be added, and from label editors, different elevations can be added to your project from here. This is editable. You can edit this as per your project requirement. I'll take out my labels. Then if you wanted to do some modifications into your walls, that also you can do. So you can modify your walls. So what you see, these arrows, you can increase the width if you wanted to, like this. With extract wall, you can extract any wall that is not been automatically extracted. You can even find walls from here. So the same thing, you will go into files. You can export this building to different formats and later on build your 3D models out of it. And then there is a direct export to Revit. So this concludes my demonstration of Edgewise. The last thing which I'll show you, the integration into Revit, how this is being done. So I'll play a video for you. So let's see how this has been integrated into Revit. The same process can be applied to. So this is all from my side. I would like to take questions if there is any from the group, and then we can conclude this session.
Yeah, thanks, Mr. Anirudh. Any question from anyone? No questions.
Sir, I have a question.
Yeah, please continue.
Sir, when you are connecting and cleaning the pipes, so there was option called ortho snap. So what was the function of that?
So ortho snap in 3D terms, you see what happens. There are couplings that is related to the pipe. So for that it is used. It's not just like you create vector layers in ArcGIS. It's totally different from that.
Okay. Thank you, sir.
Thank you.
Yeah, good afternoon. Thank you for the wonderful and dynamic presentation. I would like to ask you just one thing. What if I have to look for the applications in forestry sector, measuring the tree biomass, etc.? So how good will this instrument be in that case?
So for forestry, if you wanted to define tree species which is not covered by UAVs, because sometimes what happen due to tree foliage, UAVs is not able to penetrate down on the ground. So it's a combination of UAV plus laser scanner that you will be capturing your 3D point cloud data. Later on, you can build libraries, tree species libraries or foliage libraries on that basis. So this is one application I can identify for if you wanted to do a biodiversity mapping for trees and forests.
What about volume estimation?
Volume estimation for trees, you wanted to do it?
Say for that matter, patch of a forest.
Patch of a forest. So yes, but it should be a combination of both, because since it will depend on the tree size and foliage, you need to capture the data from 360 view. Sometimes it's a dense forest, you won't be able to capture the top of the tree from the ground. But hybrid, I would suggest you to utilize a hybrid mapping for it.
Thank you. Thank you very much.
Thank you.
Anyone else? Mujahid? Raghu?
No, sir.
Bhavneet? Sugandha?
No, sir. No, sir.
Gajendra people?
No, sir.
मजा आ रहा है?
Yes, sir.
चलो, thank you. और Nada? Praveen Shyam? Ravi? So most probably all the students have understood your, and for all the remote sensing personnel who are working in the field of remote sensing and GIS, I would like to say that Mr. Anirudh Singh is a close friend of mine. We did our masters together. So you can see the amount of energy and the amount of versatility he has, not only in the field of remote sensing and GIS, but also in the field of building information system or laser scanning, total station. So when he was giving the presentation, I was so happy that a remote sensing person can equally work in the field of architecture, civil engineering, and how the advancement of instrumentation and technology has enriched or matlab, because many times because we are remote sensing personnel, so always we talk about remote sensing and GIS. But today, when I saw this and its application, that was outstanding, and I can see a lot of future, a lot of career prospect in it. So many of the students who are pursuing remote sensing and GIS degree can take Mr. Anirudh Singh as a team. What you can visualize him as a role model for your career. And parallelly, if you want to do or you want to have good money apart from, because he is earning good amount of money, that I know personally. So if you are money oriented as well as career oriented, so not only you can have a career in remote sensing and GIS as a geospatial expert or a GIS engineer or a remote sensing engineer, but also as a surveyor, general manager, and I like to have 5 to 3 minutes of career counseling from Mr. Anirudh Singh, so that the students who are pursuing remote sensing and GIS degree can also think in this dimension, because many times we can be monotonous in our approach. But today when I saw it, I was very happy. But at last you need software scaling and communication skill, presentation skill. I always put an emphasis on that, because at last whenever you're going for surveying, you must be very technically correct, and you must have a good personality and a communication skill, because the person will identify you. He's not seeing the product, First, he will judge you, your confidence, and if he is satisfied with all your verbal and the cost effectiveness, then only he will ask for a demonstration. And finally, you have to satisfy that all the product, that whatever he is feeling that he is going to pay the amount of money that he's thinking of, and that has to, because this all projects what he is talking about is not he's talking about 1 lakh rupees or 2 lakh rupees, but the project whatever he was showing, the digital elevation models or whatever point data count he has created will cost you around lakhs or rupees or maybe crores of rupees. So at that point of time, until unless you're not confident enough about your product, your presentation, the quality, the management, not only on the product specification he highlighted, but also on the software live demonstration he has given. So he's a all rounder. So I would like to hear some career counseling aspects from our all rounder, Mr. Anirudh Singh. Please.
Thank you, sir, for your introduction. The thing is that it's not about pursuing the same thing. So there are a lot of innovations that is happening, and this GIS and remote sensing is being attached to it. So when you consider it as a tool, you can apply it any of the applications which I mentioned, and there are a lot more also. So apart from creating a data from satellites or generating or doing production through ArcGIS, there are variety of softwares that is available that can be integrated with this data also. Right now, the industry demands are more applied driven for construction, for various projects like mining, which are two segments I can recall, which has a lot of money and which emphasize of using a more efficient instrument that can give results very fast. So on that basis, you can build on to your technology, you can utilize this applied geoinformatics knowledge, and then you can enter this field. Now, as far as survey, most of the time I have seen students only driven with producing the data from satellite imagery or doing photogrammetry. But there is a separate segment of this knowledge that can be applied in the field itself. So you have to be more proactive while making your connections also with people who are out of remote sensing and GIS industry. So I would request you, so I can give you one suggestion: create a LinkedIn profile, send connections to people who can give you a career advice or who can enhance your knowledge in a different vertical apart from map creation or producing vectors from your photogrammetry or satellite imagery. So this is one thing I would like to suggest. Thank you from my side.
Nada, you want to ask something?
No sir, no sir.
Okay. Bhavneet?
मुजाहिद कुछ पूछ रहा था पहले.
Okay.
No, sir. No, sir.
No, sir. Thank you, sir.
Okay.
Thank you so
So
much,
all
sir.
okay? All okay? Okay. Then if there is no questionnaire, then on the behalf of Center for Climate Change and Water Research, I, Dr. Suraj Kumar Singh, take this privilege to thank Mr. Anirudh Singh from Topcon that he has shown us the latest techniques, technology, instrumentation in the field of surveying and how GNSS and the GPS technology, the data receiving, capturing its basics, principle, functionality, application, hands-on exercise. And this was a very outstanding session till date what we had in the last 8 days. And I thank that on Sunday you have given your valuable time from your busy schedule, and we hope that in near future also you will be blessing our students and you will be providing career counseling to them. And we hope that you achieve more success in life and you achieve all your dreams that you have dreamed of. And with this, I thank a lot again from SGV.
So thank you, sir, for providing this opportunity, and you are always welcome. That I'll be a part if if you are creating a path for your students for success. I wanted to be a part of this journey. So whenever you will invite, I'll make sure I'll have a time. Please stay safe, stay healthy, and mark social distancing. Thank
Thanks.
you.
Thanks.
Thank you
Thanks.
from my side.
Thanks. And with this,
Thank
we
you.
end today's first day session. Again, we'll be meeting at uh, 2 o'clock for your practicals related to GPS data, import, export, and data processing in QGIS environment. Majid, anything you would like to add?
Actually, it was a very interesting session, I must say. I have attended so many summer schools, uh, uh, being a guest faculty as well, for so many things. But undoubtedly, I will say with confidence that this was one of the best sessions where we could learn so many things and new technology, where the GIS has reached right now.
Yes.
We are still with creating point line and polygons, but in reality the GIS has gone too far, and there are so many applications in varied fields. I must say that this is the best opportunity for every one of us, not only for the participants, but all of us, that we are learning the potential, actual potential of GIS and actual fields where we can try our luck in future. So thank you, sir. Thank you for this opportunity.
Thank you again, and thanks a lot for continuous guidance, help, and support for throughout the program what we had till today. And again, I hope that we'll be meeting at 2 o'clock. By then, we'll have our lunch and we'll meet at 2. And for this 21 days, I assure you that each and every day will be as beautiful as your Sunday, what we have today. So we are coming up with more good speakers coming up, because the champion speakers will be coming up by end of the sessions. They are also very champions, but gradually we are mixing our labels, and big names and big tycoons will be coming at the end of the sessions, because many time the students are fascinated with the names rather than the knowledge. But whoever has delivered a lecture in my this I'll take this privilege to say as my workshop 21 days sponsored by DST. We have got the best speakers, we have got the best trainers, and all are recorded session. So I take this privilege. I'll throw this. Give this as a challenge to any of the other institution who are carrying the same program anywhere in India. We have got the recorded session, and continuously from 10 o'clock till 5 o'clock. There is no breaks for last 8 days, and we are having continuous uh, good amount of participation, good amount of interactive session, and hands-on training experts. So I don't have any confusion in my mind. This is one of the best what I can say the DST sponsored program that the DST has sponsored us, and we thank DST for having believed us, having believed that being a private university, we have the manpower, we have the infrastructure, we had the talent, we had the entire infrastructure. And finally we feel that by end of 21st day, when it will be in the form of some good projects coming up, today we'll be sharing the names of the groups and the group members name within 1 or 2 hours in your closed WhatsApp group. And uh, thanks a lot again. We'll meet at 2 o'clock. Okay, have a great day ahead. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.